Previous class, we started discussing about the second order circuits, and we started with the finding out the initialization or finding out the initial parameters to solve the second order differential equations. As we already discussed that you require two initial conditions to obtain the roots of the differential equation or the solution for the differential equations, right? So one is the voltage across the capacitor or the current through the inductor at 0 plus time, and the second one is the derivative of the voltage across capacitor at 0 plus time or the derivative of the inductor current at 0 plus time, right? So let us try to solve some more problems on this. So let us assume that you have circuit something like this. Say it is 6 amperes. So this is 2 Henry and this is 5 ohm, and this one 1.5 farad, and this is 4 U of t, 4 into U of t. All right. So assume that, so this is the voltage across resistor VR, and this is voltage across capacitor VC, and this one voltage across inductor VL, and this is IL, current through inductor, current through capacitor IC, and the current through resistor IR, right? So for this particular problem, so what you have to calculate is, so IL of 0 plus IC of, sorry, VC of 0 plus VR of 0 plus. So along with that, you also calculate DIL of 0 plus by dt, DVC of 0 plus by dt, and D 0 plus by dt, and IL at infinite, VC at infinite, and VR at infinite. So these 9 things you're supposed to calculate. All right. Okay. So let's try to solve this one. The first one, so what is the first one? So IL of 0 plus. IL of 0 plus. So that means first thing what we have to calculate is IL of 0 minus thing. So you need to calculate, right? So how to calculate IL of 0 minus? So you need to draw the equivalent circuit for t less than 0. For t less than 0. So this is the voltage, this is current source, right? So 4 into E of t. So that means, so this entire thing is not present for t less than 0. We already discussed this. So this is 6 amperes. So this is 2 Henry, and this one is 5 ohm, right? And this is 1.5 farad. Okay. So this is IR, IL, and this is IC. So now tell me, what is the value of IL 0 minus? What is the value of IL 0 minus under steady state? What is the value of IL0 minus?
So 6 ampere.
6 ampere, sir.
What is the direction? See, this is
Minus-
assumed IL
minus 6
direction.
ampere.
Minus
6.
So this is short circuited. The inductor is short circuited under steady state. This capacitor is open circuited, right? So therefore IL of 0. So what is its value? It is minus 6 amperes, right? Understood. So what is VC of 0 minus? What is VC of 0 minus? What is VC of 0 minus? This capacitor is open circuited, right? So now this capacitor is open circuited. And what is the voltage across that capacitor? Simple question.
So 0.
0, sir.
0, right? So here this is short circuited. So all the current that is flowing through, so this short circuit only. So therefore the current through this resistor is 0, right? The current through this resistor is 0. So therefore, so there is a short circuit appear across the capacitor terminals. So therefore the voltage across the capacitor is 0 volts. Right. Similarly, for example, if you want to calculate, this is VR, right? So what is VR 0 minus? What is VR 0 minus?
So 0 only.
0
Zero
only,
only,
right?
sir.
The current that flows through this resistor is 0. So therefore the voltage across the resistor is also 0. Right. So what is the first question? So this is also equal to IL of 0 plus, right? Agree? And this is also equal to VC of 0 plus. And so will it be equal to IR of 0 plus? Is the statement correct?
No, sir.
No, sir.
So
No,
this
sir.
statement is not correct, right? So what we have to do is we need to find out so this value, right? So we need to find out this value. All right. So how to find that? So how to find that particular value is, right? You need to draw the circuit for t greater than 0. So this will be the circuit for t greater than 0, right? Agree? Except this, instead of 4 u of t, you have this 4 amperes, right? Agree? This is the circuit, right? I'm not drawing it again. Understood? So this is the circuit for t greater than 0. Only the difference is 4 u of t. I just changed it as 4 amperes. Right? So now our objective is, so how to find the voltage across resistor. So that means voltage across resistor for 0 plus time. Right? So you cannot directly obtain that one. So one way is to obtain that. So you to find out the current through that resistor, IR of 0 plus. Right? So if you know the current IR of 0 plus into 5. Agree? This is the 5 ohm resistor, right? So this gives you the voltage across resistor at 0 plus time. Understood? Right? So how to find this IR of 0 plus? How to find IR of 0 plus? Any idea? Any
KCL
idea? KCL at what? So let us
at
assume
node,
that
sir.
which node?
2 Henry around that.
So let us assume that this is node A and this is node B. At
AC.
what node? At what node we need to apply KCL?
So node A, sir.
Node A. Right. If you apply KCL at node A, so this first equation, you know IC of t, IC of 0 plus, you know the value of IC of 0 plus?
Yes,
You
sir.
know the value of, what is IC of 0 plus?
Sir.
Not known, sir.
You don't, it
Not
is
known,
unknown,
sir.
right? It is yet to be found, right? If you apply KCL at node B, if you notice that, you know the value of IL of 0 plus. So this value is known to you, right? Agree? So this value is known to you. So this value you need to find out, and this is the current source, right? So now tell me, so what is IR, what is if KCL at node B. So what is this value?
Sir, IR is 0.
Hmm? So what is
VR
that
equal
value?
to
So incoming current, right? So IR of 0 plus, which is equal to outgoing currents, IL of 0 plus 6 amperes. Agree? So what is this value? IL of 0 plus
-6.
-6 ampere.
minus 6 plus 6, right? So this value is 0 amperes. So therefore, so what is VR of 0 plus? What is VR of 0 plus?
0 volt.
It is 0
0.
and it is multiplied with its resistance. So that is 0 volts. Understood? Okay. So we have obtained all these three things. So IL of 0 is over, VC of 0 plus is over, and VR of 0 plus is over, right? Understood. So next thing, so we need to calculate its first derivative at 0 plus instant. So let us calculate dIL of 0 plus by dt. Right. So in one of the class we discussed this. So how to calculate this one? How to calculate this value? So the simple thing, so L into di of 0 plus dt equal to voltage across inductor, right? So voltage across inductor VL of 0 plus, so which is equal to L into dIL of 0 plus by dt, right? So from this, so what is the value of dIL of dt? So what is this value here? In terms of dVL, it will be equal to VL of 0 plus by L, right? Agree?
yes, sir.
Okay. So what is our next objective? So our next objective is to find out VL of 0 plus. Right. So tell me how to find so VL of 0 plus.
By applying KVL.
KVL. Yeah. In which loop? So here, here, or here?
Inner loop. Means middle
Middle
loop.
one, right?
Yes,
So
sir.
tell me if you apply
Yes, sir.
KVL, so what you will get? With that, we already indicated the voltage across inductor, resistor, capacitors. Everything we indicated, right? So now tell me, so what is equation you will get? So
Sir,
apply
VL plus VR equal to VC.
apply KVL at inner or at inner middle loop, right? KVL in the middle loop. So tell me what you will get.
VL minus VL plus VC minus
No,
VR.
VR of 0 plus, right? So this is plus minus. If you assume that the current is rotating in this direction, right? So plus minus. What is the next one? So this VL also plus, right? So VL of 0 plus,
Yes, sir.
agree? And for capacitor, it will be minus, right? So which is equal to 0. All right. So VR of 0 plus we already calculated, right? So what is VR of 0 plus? So this is 0. And so this is we need to find out. And VC of 0 plus, what is VC of 0 plus? So
0,
this is
sir.
also 0, right? So from this, right? So from this, what is the value of VL of 0 plus? What is the value of VL of 0 plus?
0.
It's 0 volts only, right? 0 volts. So now tell me what is DIL of 0 plus by dt. So this is 0 ampere per second. Clear? Understood? Understood?
Yes, sir.
Okay. Shall we proceed to the next one? Or you have any doubts in this? Right. So what is the next one? What is next one? dVc of 0 by dt. Right. So what is dVc of 0 by dt in terms of capacitor current? So this is equal to IC of 0 plus. This is the one, right?
Yes, sir.
Okay. So now tell me what is IC of 0 plus.
Sir, we'll apply KCL at node A, sir.
Yeah, good. KCL at node A. So what is KCL at node A?
Is equals to IC plus IR.
What? 4 is the incoming current, right? 4 equal to outgoing currents, IC of 0 plus IR of, no. Yeah, is this correct? Is this correct?
Yes, sir.
Okay, so from this IC of 0 plus is 4, right? So that means this value is 4 by 1 by 5, 1 by 5 only, right? So this is 20, plus 20 or minus 20? Plus 20 only, right? So 20 volts per second. 20 volts per second. Understood? Right? So next we proceed to the next one, so which is V dVr of 0 plus by dt. Okay. So unlike this capacitor voltage or the capacitor current, there is no direct relation, right? So here the simple technique is, if you have inductor current derivative, so we used this expression. If it is a capacitor current derivative, capacitor voltage derivative, so we used this expression, right? But for resistor, so the first derivative of the resistor, so we have no such expression. So what we have to do is, right, so this one dVr of 0 plus dt, so that means, so this is somehow or somewhere, if we apply KCL, so we will find out this Vr of 0 plus, right? So differentiating this one, so you will get dVr of 0 plus by dt. Okay, right? So now identify a equation or a KVL or KCL, so where you will get, so this dVr of 0 plus dt, okay, where you will get, or where you can solve the dVr of 0 by dt and its derivative term. So if you notice that, so for example, if you have Vr of, if you apply KVL here, for example, this is the equation. So focus on this equation. So focus on this equation, right? So if you derivate this one, so you will get dVr of 0 by dt term, right? Agree? And dVl of 0 by dt term and dVc of 0 by dt term. So three things you will get. But the thing is that, so here, so you are aware of this dVl of 0 by dt term. So I will write here. So what is that equation? So dVr of 0 plus Vc of 0 plus minus, this is plus, right? This is the one, right? Agree? Is this correct? So this is the equation, right? So if you derivate this one, so dVr of 0 plus by dt plus dVl of 0 plus by dt minus dVc of 0 plus by dt equal to 0. So here this is you want to find out. So you know this value. Do you know this value? You know this value, right? What is the value of this one? dVc of 0 by dt, it is 20, right?
Yes, sir.
You know this value, you don't know this value, right? So that's why, so this equation is, there is no help from this equation, right? So what are the other options you have? So you can also apply KCL at this node, right? So we'll try this one. If you apply KCL at this node, so what is the current IR, right? So if you apply KCL at node B, KCL at node B, there is another option. So what you will get if you apply KCL at node B? What is the equation? What is the equation KCL at node B?
Sir, sir, VR 0 plus upon 5, sir, is equal to IL plus 6 ampere.
Yeah, IL plus 6 amperes. Good. All right. So this VR of 0 plus, so that is IR of 0 plus. So that means you know the current value, right? So instead if you are confused with that, so this will be IR of 0 plus, right? So what he did is instead of this IR of 0, this is one we required, right? So here written in terms of VR of 0 plus by 5 equal to IL plus 6. So you can differentiate this one. So differentiate with respect to t. So what you will get here if you differentiate with respect to t? So this one, what is the first term? What is the first term if you differentiate this one? So 1 by
DVR.
5 into dVr of 0 plus by dt. So that is the first term. So which is equal to dIL of 0 plus by dt. So 6 derivative, so that is 0. So from this, what is dVr of 0 plus by dt? So what is the
0.
value here?
0, sir.
0. Okay. So dVL of this is 0. Okay. So that's why. So this entire thing is 0. So 0 volts per second. Understood? So this is how you will find the first derivative of this dVr of 0 plus by dt. Clear? You have any questions? No. Right. So what is next? What is left here? For t infinite time, if t infinite time, so we need to find other things, right? IL of infinite. So what is IL of infinite in this circuit? What is IL of infinite? What is IL of infinite? What are the various currents? So that is passing through this resistor, this inductor. That means inductor is short circuited, right? What are the various currents? So that passing through this inductor, that is the IL of infinite, right? So now tell me. So this particular inductor is now short circuited. So this capacitor is open circuit, right? Agree? So that means this
Sir.
is short circuited. So 6 amperes current. So that means 6 ampere current is flowing in this direction. And this 4 ampere current is flowing in this direction, right? Agree?
Yes, sir.
Agree? So what is, if this is IL, what is the net current that is flowing?
2 ampere.
Why 2 ampere? Just
Um,
see the sign.
-2.
So IL, so this is IL sign, right? So that is in downwards. So downwards you have 4 ampere current flow. Upwards you have 6 ampere current flow. So due to this, right? So you're aware this, right? Why this 4 ampere? So this is due to this source. Because this capacitor is open circuited. So only the current must flow through this resistor only. Right. So therefore it will be 4 minus 6, which is equal to minus 2 amperes. Understood? So what is VC infinite? What is VC infinite? What is VC infinite? Voltage across this infinite. What is VC infinite?
Sir, 20 volt.
Yeah. How exactly it is 20 volts? So this is short circuit, right? If you are unable to follow, we'll draw the equivalent circuit. This is capacitor, this is open circuit, right? So this is VC and this is IL. This is 4 amperes and this is 6 amperes, right? And this is 5 ohm. Is it 5 ohm? Yeah, 5 ohm, right? Now tell me, so what is inductor current? So you're aware of this one, right? So 4 ampere, 4, it will flow like this, and the 6 ampere will flow like this. So therefore the overall current is minus 2 amperes. So now tell me, what is VC? What is the current that flows through this resistor?
4
If you
amps.
observe that
4 amp.
here this VC, so one point is connected here, and another point is connected here, right? That means another point is connected here, right? So whatever the voltage across the resistor, right? Whatever this voltage across this resistor, so both are same, right? Agree? Both are coming parallel, right? If this one, so this one and this one, so both are coming in parallel, if you notice that. Agree for that?
Yes, sir.
Okay. So
Yes,
now,
sir.
so what is the voltage, what is the current through this 4, this is 4 amperes is flowing, right? So therefore this is equal to 20 volts. So this is also equal to 20 volts, right? So that means VC at infinite, so that is 20 volts. Similarly, that is another one we require is VR at infinite, right? So this is also 20 volts. Done. Clear? Okay. So any questions here? You have any doubts? Okay. So I will give an example. So try to solve. This is VR and this is VC and this is IL. Okay. So calculate all these things. IL infinite, IL 0 plus, VC 0 plus, VR 0 plus, and its first derivative, and its steady state values. So that is IL infinite, VC infinite, and VR infinite. Okay. Right. Some of may confused one thing. Just listen. Right. For example, you have 2 into E of t is there, right? Okay. So 2 into E of t. What is the equivalent circuit for t greater than 0? What is the equivalent for t greater than 0? So this thing is open circuited or short circuited?
Short, sir.
Open circuit.
Open circuited, right? What is the meaning of 2 into E of t? Right. So for t less than 0, its value is 0. Okay. For t greater than 0, so E of t value is 1. Right. So meaning is, so you have 2 ampere current source. Right. So this current source is 0. So that means this is open circuited or short circuited?
So open circuit.
Open circuit, right? If you have current source, so that will be open circuit. Same thing, for example, this is 10 into U of t is there. So how you will deal this?
So for t less than 0, sir, again, sir, open, sir, no, sir, it will be short circuited, sir.
Yeah. Okay. So for 10 into E of t, for example, this is voltage source, right? So this 10 volts, for same thing, for t less than 0, U of t equal to 0. For t greater than or 0, so E of t equal to 1. So t equal to 0 means for t less than 0, right? So this source is short circuited, right? So 0 voltage means short circuit, right? So we need to treat this as a short circuit in this particular case. Understood? We need to treat this as a short circuit.
And capacitor will be also short circuited.
Hmm.
Capacitor will be also short circuited now.
Why capacitor is short circuit? This is the circuit. So you have voltage source is there. So this thing you are short circuiting, not the capacitor.
Okay, sir.
Okay. Right. So that thing you remind. So for t greater than 0, so this is represented as a short circuit. For t greater than 0, so its value equal to 10 volts only. Right. So its value is 10 volts. That's all. Okay. So try to solve this one. Try to solve this one. So I will provide the answers. So this is about finding out the initial values for differentially for these circuit parameters, okay, for the second order circuits, right? So next we'll start with the next one. So one is the source free response of source free response of RLC series circuit, right? So the circuit will be something like this. Source free response means, so there is no excitation, right? So this is capacitor voltage VC, inductor current or the overall current IL. So since it's a series circuit, and here R, so this is L, and this is C. Right? So the current that is actually flowing is I, for example. Okay. So let us assume that for t less than 0, so we have some initializations, IL of 0 minus, so let us assume this is I naught, and VC of 0 minus, so which is equal to V naught. All right. So our objective is, so what is the response for this particular circuit? So how, what kind of response, what kind of current response, so you have for this particular circuit? So that is our objective, right? So how we are achieving this one? The first thing is we need to write the differential equation for this circuit, and we need to solve that differential equations by finding its roots. Okay, right. So let us assume that this V I of 0, from this I of 0 equal to I naught, right? Agree? So this I of 0 equal to I naught, right? Similarly, so V of 0 or the voltage across capacitor VC of 0. So what is VC of 0? So which is equal to V naught. So this can be written as 1 by C integration of I dt, right? Agree? So what are the limits for this one? What are the limits for this integration? Can anyone tell?
T less than 0 to t equals to 0, sir.
See, this is V naught, right? So we are equated this to V naught. So then what are the possible limits? So for this particular V naught. So when it will be V naught, right? So here, this is agree. This is correct, right? So
Yes,
here,
sir.
so what are the possible limits? What we expect that the switch is closed or we have some source, so which is excited from minus infinite time, right, and up to 0 time, right? Agree?
Yes, sir.
Yes,
You agree with this? Similarly, for example, if you want to write Vc of t, so how you will write Ic of t? So minus infinite to set some t value I dt, right? This is the same way I have written. Understood? The only thing is I know that.
Sir,
So I'm
direction
aware that.
of I will minus I.
Why minus I?
Sir, because sir, VC sir direction sir is plus sir sir
This is
side sir
plus
it is
only, right?
plus
This
now.
is I, right?
Okay sir, okay sir.
Okay.
Yes sir, got sir.
Right. So this is the one. Just keep this aside. Right. So now if you apply KVL in this loop, right? So what you will get? R into I, right? First term. L into di by dt, the second term. So what is the third term? The third term. So it will be 1 by C integration of minus infinite to t, right? Some I, some x, some random value x into dx equal to 0. You are agree with this? You are agree with this?
Sir.
Yes sir.
Our meaning is I equal to I of t, right? So this is the one, right? Our objective is to find out the response of current I for some particular time t. So what is the next step? So how to solve these kind of equations?
Laplace transform.
No, Laplace is, we'll use Laplace at later point of time, right? So how to approach these things? So this is one side you have derivative, one side you have integration, right? So how to bring it to the second order differential equation?
Differentiates.
Differentiating again.
So differentiating again, right? So what you will get if you differentiate again, and tell me what is the final expression you will get? So differentiate this again and tell me what is the final expression you will get in terms of d square I by dt square, something like that you will get, right? What is the final expressions you will get? So differentiate this one.
L di square by dt.
So this r into di by dt plus L into di square by dt square plus 1 by c into I, right?
Yes sir.
So which is equal to 0. If you rearrange this one, so will it be di square by dt plus, what is the next term? It will be r by L into di by dt plus I by RC. Sorry, RC or LC into equal to 0, right? Agree? So I just divided with L. You are agree for this?
Yes, sir.
Okay. So what is the expression you got? Di square by dt plus r by L into di by dt plus I by LC, which is equal to 0. So this is a second order differential equation. So that our objective is to solve this second order differential equations. As we already said, so you require two initial conditions, right? So one initial condition is, so these two are so things that we need to use. So another initial conditions, you can either use this one or this one. So what is the another equations? That is the derivative of this one, right? So derivative of, so this expression, if you apply this one, for example, in the same case, okay, in the same thing, what is the first derivative? So how to write this one in terms of for, so same expression for t less than 0. So how this expression will change? So how this particular expression will change? R into I of 0, right? So for R into I of 0 or for t equal to 0, so R into I of 0 plus L into di of 0 plus, so what is this value? So what is this entire thing? In place of t, 1 by c integration of minus infinite to 0 I 0 into dx. So what is this value? R into I naught plus L into d I naught by d of 0 plus. So what is this value? So this is V naught, which is equal to 0, right? So from this, d into I of 0 by dt. So what is d into I of 0 by dt? Minus 1 by L into R I naught plus V naught, right? Agree?
Yes, sir.
Understood? So how this equation is transformed? So this R into I of 0 plus L into di of 0 by dt, 1 by c into integration of I of, right? So I of minus infinite to I of 0 into dx, right? Sorry, this I of x only. Understood? So we already discussed that. So this value is equal to V naught. So therefore the overall equation is di of, this is the another equation. Anyway, we'll come back to this equation again. So here, so next we have what we obtained is a differential equation you obtained. So d square I by dt square plus R by L into di by dt plus I by LC, which is equal to 0. Right. So here the solution, so I is in which form? We already studied this, right? So I is in something like this, a into e to the power of some s into t form, right? Agree?
Yes, sir.
Yes, sir.
This will be the one possible solution, right? So substitute this one. So substitute I value and tell me, so how this differential equation is. The first one is as square into e to the power of st. Just correct me if I'm wrong. Plus a into r by L e to the power of, sorry, s into e to the power of st, right? Plus a e to the power of st by lc, which is equal to 0. Is this correct?
Yes, sir.
Yes,
So if you
sir.
separate a into e to the power of st term, right? So what you left with the first term? S square, right? Plus r by L into s plus 1 by LC equal to 0. I hope this is correct.
Yes, sir.
Okay. Right. So this is solution, right? So from this is the one we expect, right? So this can't be 0. So that means only thing that is 0 is s square plus r by L into s plus 1 by LC, which is equal to 0. So what it is known as? What it is known as? You might have studied the differential equations, right? What is the name for this one, right? So this is known as characteristic equation, right? Have you studied this? So this is known as characteristic equation. So this is known as characteristic equation for this particular differential circuit, for this particular differential equation. S square plus R by L into S plus 1 by LC equal to 0. Right. So this is characteristic equation. So you have two roots. So you have one root S1 and the root S2. So what is S1 here? What are the roots for this characteristic equation? Minus, what is the roots? Minus b by 2 plus or minus root b square minus 4ac, right? So what is the root for this equation? Minus r by 2l plus square root. What are the roots for this equation? Anyone tell me what are the
Sir,
roots for this?
minus r upon 2l, sir, plus minus under root r square upon l square minus 4 upon lc whole upon 2.
Yeah, tell me again. Minus r
Sir, upon 2L, sir.
2L plus
Plus under root R square upon L square. So minus 4 upon LC.
minus 4 upon LC.
LC. So whole
This is
upon
plus
2.
or minus. Whole upon
Sir, whole upon 2. Sir, means, sir, the only the root part, sir. Whole
this
2.
is the under root. This is also under root, right?
No, sir. No, sir. That is out, sir.
That is outside.
Yes, sir.
So this is S12, right? Okay. So can you rearrange this one? Right. So can we rearrange this one? So if you rearrange this one, it will be minus R by 2L plus square root R by 2L whole square minus 1 by LC. Just check it out. So both are same or not?
Same, sir.
Same, sir. Same, right? So this is S1. So what is S2 value? Minus R by 2L minus square root R by 2L square minus 1 by LC. So these two are the roots for particular or roots for this differential equation. All right. So there is a possibility that, so we have different possibilities are there, right? So depending on the situation, so we have different possibilities, right? So these roots may be real, right? These roots may be real. So when these roots are real, or these roots may be imaginary, right? Or roots may be imaginary,
Yes.
or roots may be equal. Or roots may be equal. So when these roots are equal,
So when the root part is 0.
when the root part is 0, so that means R by 2L equal to 1 by LC. So under particular case, the roots are equal, right? So that means there are three possibilities are there. So let us reduce this one. So let us assume that alpha equal to R by 2L, alpha equal to R by 2L, right? And this 1 by omega 1 by LC can be written as, or you know that omega not equal to 1 by square root LC, right? You're aware of this, right? Okay.
Yes.
So what are the roots now? S12 now. So how these roots will change? It will be minus alpha plus or minus square root alpha square minus omega naught square, right? Agree for this?
Yes, sir.
And how this equation will change? How this particular equation will change? S square plus 2 alpha s plus omega naught square is there, right? Omega naught square equal to 0. Understood? S1, S2, so that is the roots. So it is minus alpha plus or minus alpha square minus omega naught square under, right? Okay. So here, in this particular case, this omega naught, so which is known as undamped natural frequency. So we'll discuss that. So what is damping and what is undamping, right? And this alpha is known as damping factor. Alpha is known as damping factor. So what is damping is simple, right? So let us assume that if something is a ball is bounced, right? So how it will oscillations, it will be something like this, right? So this entire thing is known as damping. Okay? So for example, you have bounced a ball, or if it is hitting the ground, so it will go high, right? So now it is fall down, it will fall down like this, right? So this is the particular thing it's making, right? So that is known as damping. What is undamped means? What is undamped? Right, it is moving like this. So there is no loss in the energy. Whatever the positive cycle, negative cycle, positive cycle, negative cycle, same. So that means it is never reached to zero. It will never reach to zero. So this is known as undamped. And this is known as damped. Right. So we'll discuss this more. Just I given brief introduction of this. What is damped and what is undamped. All right. So now, so we have three possibilities, right? So we have three possibilities, and usually this S1 and S2. So there's the roots, right? Characteristic equations roots. So these are known as natural frequencies. So that dictates the solution of this differential equations, right? So we have three possibilities, right? So we have three possibilities. So one is alpha is greater than omega naught. Alpha is less than, we have two roots there, right? S1, 2. So what is the roots? Minus alpha plus or minus alpha square minus omega naught square, right? And alpha equal to omega naught, alpha less than omega naught. Okay. So this alpha is known as damping factor and omega naught is the resonant frequency or undamped natural frequency. Right. So this is resonant frequency or undamped natural frequency, right? So we have one condition, alpha is greater than omega naught, alpha greater. So this is known as overdamped. Yes.
Yes. Sir,
And this is known as critically damped. Yes. S1, S2 are known as natural frequencies. We will discuss that. What is those things? Okay. Critically damped case, and this is underdamped case. And this is underdamped case. So visually we define zeta, right? So zeta is known as alpha by omega naught. So this is known as damping ratio. So this is known as damping ratio. So this is known as damping ratio. So from this, in other words, so this is zeta greater than 1, right? And this is zeta equal to 1, and this is zeta less than 1. So we have based on the solution or based on the roots. So we have two possible solutions. So one is zeta or overdamped case, critically damped case, and underdamped case. Overdamped, critically damped, or underdamped case. Right. So we'll start with, so one by one. So first we'll start with underdamped case. So where underdamped case, so where alpha is greater than omega naught, right? If alpha is greater than omega naught, so what is the fate of roots? Is it imaginary or real or complex? What is the fate of the roots?
Real roots.
Real roots.
The roots
the
are
real
real and negative, right? See here, roots are negative and real.
Yes.
If roots are negative and real, so what is the possible solution for I of t? What is the possible solution for I of t? You know the roots, and what will be the solution for I of t? It will be a1 into e to the power of s1t plus a2 into e to the power of s2t, right? Agree? Agree?
Yes, sir.
So this is the possible solution, right? So how to find this A1, A2 values? How to find this A1, A2 values? We already said that you require two initial
alpha is
conditions,
less than
right?
omega
So
naught,
based on,
sir.
yes, yes.
So for underdamped, alpha is less than omega naught.
For underdamped,
Alpha is less than omega naught.
I think I have written wrong. Just a minute. No, this is alpha is greater than, this is, no, this is over damped, right? Sorry. This is the one you're talking. This is over damped case. Okay, change this one. I think I have written wrong. This is over damped case. So where alpha is, this is the one I have written. This is alpha greater than omega naught, right? Yeah, this is, yeah, this is the one. Okay. So, okay. Sorry, I started with this under damped. Okay. The first one, so first case, right? So first case is over damped. So this is case one, over damped, where alpha is greater than omega naught. So this is the solution for this first case, right? So how to find this A1, A2? So by finding the differential equation, so you can find the values of A1 and A2. So what is the next case? Alpha equal to omega naught, so which is critically damped. Which is critically damped. So if alpha equal to omega naught, so what is S1, S2? So what is the value of S1, S2? So which is equal to minus alpha, right?
Negative
So which
and
is
equal.
equal to minus R by 2L. Is this correct? Is this correct? So what is the
Yes, sir.
differential equation? So d square I by dt square plus 2 alpha into di by dt plus omega naught square, so which is equal to 0. So that is the differential equation you have, right? So that is the differential equation you have. So now you are aware that alpha equal to omega naught. So now how this differential equation will change? D square I by dt square plus 2 alpha into di by dt. So this can be written as alpha square equal to 0. Agree? Agree?
Yes, sir.
So now we'll distribute this one, d square I by dt square plus 1 alpha into di by dt plus another alpha into di by dt plus alpha square equal to 0. So now separate di by dt term here. So what you left with? So first another di by dt. So what is the one you left? Alpha into I, right? Agree? From these two. From this, if you separate, something, this is alpha square into I, right? So this is also alpha square into I. So they have. So what is the next term? If you separate alpha, so it will be di by dt plus alpha I equal to 0. You agree with this? You agree with this?
Yes, sir.
Okay.
Yes, sir.
So if you notice that, right, if you notice that this is in the form of if you observe that this is in the form of first order differential equation. So if you see that this is di by dt, if you assume that di by dt plus alpha I, which is equal to some function f, for example, so it will be in the form of df by dt plus alpha into f, which is equal to 0, which is in the form of first order differential equation only, right? Agree? Which is in the form of first order differential equations. So now what is the solution for this one? What is the solution for this one? What is the solution for this first order differential equation? So will it be equal to a1 into e to the power of minus alpha by t? Agree?
Yes, sir.
You agree with this? Have you
Yes, sir.
completed this differential equations part, no?
Yes, sir.
I
Yes,
hope
sir.
it's completed, no? So this is the one, right? The solution for this one, a1 into e to the power of minus alpha t. From initial conditions, we'll find out the a1 value, right? So this is equal to f. So that means a1 into e to the power of minus alpha into t. So f is originally this one, right? So that means di by dt plus alpha I. Understood? Okay. So if you rearrange these terms, right? If you rearrange these terms, it will be e to the power of alpha t into di by dt, e to the power of alpha t into di by dt. One second. So this is the one, right? So di by dt plus alpha I, so which is equal to a1 into e to the power of minus alpha t. Right? So if you rearrange or if you reorganize these terms, so what's the one? Okay. So from this, if you rearrange these terms, or if you bring this e to the power of alpha t on the other side, so it will be di by dt into e to the power of alpha t plus di by dt into e to the power of alpha t. So what is the other term? E to the power of alpha t into alpha I, which is equal to a1, right? Agree?
Yes, sir.
Okay. Agree. I'm just rearranging these
Yes, sir.
terms, right? So this will be e to the power of alpha t into di by dt. So now if you observe carefully, so what is this term?
Derivative
So
of I
e
into
to
e
the power
power
alpha
alpha.
t into di by dt, e to the power of alpha t into alpha I. So what is this exactly?
Derivative of I into e power alpha t.
Yeah. So it will be d by dt e to the power of alpha t into I. So what is this derivative? What is this derivative e to the power of alpha t into di by dt? So that is one term. So what is the other term? I into e to the power of alpha t derivative alpha into e to the power of alpha t. Agree?
Yes, sir.
Okay. So now, so this entire thing can be rewritten as so d by dt e to the power of alpha t into I which is equal to A1. Again, integrate this one. If you integrate this one, so what you will get? So it is for alpha t into I equal to A1 into t plus some other constant A2, right? You agree with this? So
Yes,
from
sir.
this, I value is A1t plus A2 into e to the power of minus alpha t. So what is the solution for this particular case? So I equal to A1t, right, plus A2 into e to the power of minus alpha t. So this is for critically damped case. So what we already calculated I equal to, or in other words, I of t, this is actually. So what is the next one we calculate for previous case? So I of t equal to A1 into e to the power of minus S1t plus A2 into e to the power of minus S2t. So that is for, that is for which case?
Overdamped.
Overdamped case. This is for critically damped case. It will be E1t plus A2 into e to the power of minus alpha t. Just a simple differential equation solution, that's all. So next one, so we have underdamped. So where you have alpha is less than omega naught, alpha is less than omega naught. So now S1 will equal to minus alpha, right, plus alpha is also equal to something like this, right? So it means minus of omega naught square minus alpha square, S2 equal to minus alpha minus of omega naught square minus alpha square, right? Agree? Agree with this? Since alpha is less
Yes,
than omega naught, right? Understood. So here, so this one, right? So this one, you know that j equal to minus 1, right? So what are the roots for this one? What kind of roots you will get?
So conjugate
Roots are complex, right?
complex.
Roots are complex. So let us assume that, so this entire thing omega naught square minus alpha square under root. So let's assume that omega d, right? So omega d. So where this omega d is known as damped natural frequency. So we have omega naught, so which is undamped natural frequency, and alpha is damping factor. All right. So this equation can be written as S1 can be written as minus alpha, right, plus j omega d, right? Agree? S2 equal to minus alpha minus j omega d, right? So where minus 1 under square root, so we assumed as j. You agree with this? Supposed to be high, I, right? But on our electrical terms, we usually use, instead of I, we use j, right? So that's why it is minus alpha plus j omega d minus alpha minus j omega d. Understood? Right. So what is the next step? So I of t. So I of t, it will be in the form of a1 into e to the power of s1t plus a2 into e to the power of s2t, right? So substitute the value. If you substitute the value a1 into e to the power of minus of alpha, right, minus j omega d t plus a2 into e to the power of minus of alpha plus j omega d t. Is this correct? Is this correct?
Sir.
Yes, sir.
If you rearrange this one, or if you subtract e to the power of minus alpha t, you can remove, right? In other words, alpha t can remove, right? So this will be equal to a1 into e to the power of what you left, j omega dt, agree, plus a2 into e to the power of minus j omega dt. Just check it out.
Yes, sir.
Correct. So what is e to the power of j theta? What is e to the power of j theta?
Cos theta plus I j
Cos
sin.
theta plus j sin theta, right? You have already studied it, e to the power of I theta, right? Cos theta plus I sin theta. Okay. So the same way, so I equal to j, right, for electricals. So it is e to the power of cos theta plus j sin theta. So now tell me, so what is this expression? How this expression will change? E to the power of minus alpha t. So what is the first one? A1 into e to the power of, no e to the power of, right? So now A1 into, what is the first value? So what is the first term?
cos omega dt
Cos omega dt
plus I j
plus
sin
j sin
sin
omega
omega
dt
dt
plus a2 into cos omega dt minus j sin omega dt, right? So why you have written minus here? Why we have written minus?
So because there
you
was
have
minus j omega dt.
Minus j omega t, right?
yes sir.
So if you rearrange these things, e to the power of minus alpha t, cos terms and sin terms, if you rearrange, so it will be a1 plus a2 into a1 plus a2 into what you will get, cos omega dt, right? Agree? Plus j into a2 minus a1 or a1 minus a2. What you will get?
A1 minus a2 sir.
Hmm? Oh, yeah, a1 minus a2. a1 minus a2 into sin omega d t. Okay. All right. So let us assume that, so this entire thing equal to some b1 or some this entire thing equal to b. Ultimately these two are constants only, right? So that means the solution will be, so what is the solution? So e to the power of minus alpha t, so that is I of t. All right. So into b1 cos omega dt minus, plus j b2 sin omega d t. So this is for what we have. This is for under damped case. All right. Right. So we have three possibilities. So based on the damping ratios, right? So solution is in the form of one of the thing, right? So here our ultimate objective is just, this is the solution. So from the initial conditions, we need to calculate the B1 value and so B2 value, right? So next tomorrow's class, so we'll discuss that. So what is exactly this over damped, under damped, and critically damped, right? So how this damping ratio is influencing all those things. So we'll discuss in tomorrow's class. So you have any questions?